Okay, this time we're going to look at images formed in a diverging lens. A diverging lens. And we'll just do this rather quickly because we've already seen what happens in converging lenses, and a lot of it is a similar idea. Remember that another word for a diverging lens is a convex lens, but we've talked about why that's a little bit confusing. Okay, well, let's draw a picture of a diverging lens. So it's the one that's skinnier in the middle than it is on the ends. So it looks something like this. This is, well, as we'll see later, any shape that's skinnier in the middle can sort of have this lens effect. But this is the way we usually draw them in pictures, in diagrams. Okay, we need our optical center down the middle of the lens. We have our principal axis going the other way, and we're all set to go. So we need to put some focal point in. So let's put a focus here. And you can also put a center of curvature if you want. You'll notice that we don't really use the center of curvature much when we're talking about lenses. It's just not something that has much value, but it's useful for, I guess, determining the location of the object and image. Okay, so let's take a scenario. Whoops, there's an F there. Okay, and again, we have the problem of the focus on two sides, but we just have to remember what the lens does, right? So the light rays have to diverge every time we draw them. If you draw it converging, it would be wrong. So in the other lens, we knew which focus to use because we knew that the light ray had to converge or bend in towards the principal axis somehow. Here we know they have to diverge. So let's draw our object in a nice little green, and let's just put it. Let's put it here. Little arrow, something like that for the object that we're going to be looking at through the lens. Okay, I better make that a little bit smaller, sorry, because I don't want to run out of lens. That should be good there. Okay, so let's try drawing a light ray. Well, one of the light rays we can draw is parallel to the principal axis. So a light ray comes in from somewhere and it bounces off the tip of this and it goes shooting across to the lens parallel to the principal axis that way. Well, obviously it cannot go through the focus on this side because that would require it to bend downwards. And we know that's only for a converging lens. So the rule about the focus doesn't work with that side, but it does work with the other focus. So that's not correct. What we want to do is we want to find a way to make the light ray bend upwards. And if you imagine with your ruler, I'm going to draw a line to represent where you put your ruler. Right across here. Line it up with the focus. Like that. That's a line through the focus. And the light ray then can follow this way, can follow that line. So it is refracting on a line through the focus, but it's not actually passing through the focus, right? It's a little bit trickier in this sense. So now I'm just going to go back and draw the red line. We don't need that ruler imagine line. We go like this. But that is lined up with the focus on the same side. And I know that it has to be that focus because the other focus would cause it to converge, which is the wrong kind of lens. Okay, now, what if I do a line through the focus? Well, here's something interesting. Don't draw this yet, because this was going to be wrong. But if I draw a line through this focus, it's going to go down like this, and it's going to have to somehow diverge. So that's not really going to help me much either. So instead, what I can do is I can imagine what would happen if I went on a line through the other focus. So again, my ruler is going to line up along here on a line going through the focus on the other side. And so then I know that if I draw that, I'm going to erase my ruler line now. If I follow that path with my blue light ray, and it's going down towards there, it's going to stop and bend at the optical center, and it will bend because it's on a line going through a focal point, it will diverge and bend out nice and straight, parallel to the principal axis. So that's a trickier thing to do too. You really have to use your ruler and imagine where the lines are through the focus. Does everybody see how I did that? Okay. And then we notice that these lines are not crossing. An eyeball on this side would not see any lines crossing to make any real images, but we can always do the old where do they look like they came from routine. So if I take maybe I'll take a different color. I'll take the purple color here, and I'll extend the rays. Now remember, we're extending the refracted rays, the rays that the eyes see. We're not extending the rays over here because the eye doesn't see those. It's what's on the other side. So we're extending this one right here, and we know where it goes because we lined it up with our ruler to go through the focus. So we know it's going back there through the focus, right? And the other one is parallel, so it's going like this, straight along like this. And lo and behold, there's a spot where they cross right here where my little tiny image would be. So the eyeball looking into this lens from over here on this side would not see the green arrow on the other side of the lens, even though light goes through the lens. If this was a plain piece of glass without any curves, then you'd look and see the green arrow because everything would be straight. But because of the curves and the way the light bends, we see a different image. We see the little tiny purple arrow. This is like the opposite of a magnifying glass, isn't it? It makes the image a little bit smaller. So this lens is not very useful for magnifying, but it does have a very important use that we'll see later on. Okay? What you would see then is the apparent picture of the little purple arrow, which means the location inside F, the upright orientation, upside right, for the purple arrow, right? Okay, sorry we got interrupted. We're back. Upright image, and then we were talking about what the eyeball sees. So this image is actually a virtual image, right? If we were talking about real and virtual, a virtual image. Oh, and also smaller. That was the other thing. So those were the characteristics of this image. And what's interesting with the diverging lens, much like the diverging mirror, you're always going to get virtual images. So there's really only one particular kind of picture that you can draw with this lens. You don't need to draw all the different locations because this is really the only result that you're going to get. So that's it for the diverging mirror. It's actually quite simple. So before we just wrap up, I just want to make a note of a couple of things about lenses. So, you know, where we would use a lens like this. And obviously, a converging lens makes a very good magnifying glass. We saw that. So that's one of the most common uses where we hold the magnifying glass in front of an object and see a bigger image. But the diverging lens, because it diverges, it's actually a very good way to correct for nearsightedness, which is caused by an over-focusing of the lens of your eye. Let me just kind of explain that. So your eyeball, here's your eye from the side. This is the little black hole where the light goes in. The black spot of your eye, the pupil, is actually just a hole. It's wide open. But there's a bubble over top of that hole called the cornea that protects things like dust from getting into the eye. But light can go right through the cornea. If you look at someone sideways, as they stare straight ahead, you'll see the little bubble on their eye, the cornea. But it's clear. And so light can go in, and inside here, there's a converging lens, a lump of protein, basically, but it's got the shape of being thicker in the middle than it is on the ends. And so what's supposed to happen is when light comes into your eye, it's supposed to go through the pupil, hit the lens, and bend downwards and focus onto the retina right there. nice and sharp. They meet right on the retina. But some people, because of their genetics, they have an eyeball that's a little bit too long. So let me just draw that. The shape of their eyeball is a little bit longer, oval shaped, like this. Right? And there's the, well, wait a minute. Let me try that again. Here's the cornea. And then the eyeball is sort of, I'll draw it a little more exaggerated there, like that. So what happens is, when they have this lens in their eye, what happens is the light goes through the pupil and it bends, but it bends like this, and then it comes through here and it bends like this. Whoops. Wow. My drawing. And it bends sort of up like that. See, this is where the normal eyeball, the normal shape would have been. But they don't have that. Their eye's too long, which means this is where the image is formed. This is your retina. You're going to get a blurry image on the retina because the lines aren't meeting very, very well. And that's what's called nearsightedness. It means that things that are far away become blurry in your eyesight. Many, many people are nearsighted to some degree. So how do we fix it? Well, watch what we do. It's actually very clever. We use a lens. I'll have to draw this a little more carefully. There's the cornea. There's the long eyeball that's sort of the wrong shape. Okay? What we put is a diverging lens out here, which is called your glasses, or a contact lens. Your glasses are actually thinner in the middle than they are on the edges. And so what happens now is a light ray will go in here, hit this lens, and it'll diverge a bit. It'll bend outward a bit. So there's a little bit of diverging. I didn't draw that very well. I'll try again. A little bit of outward bending, like that. Oh, wait a minute. I'm still not drawing this very well. I'm trying my best. Diverging. There, that looks better. There. See, they're spreading out. So when they hit the lens of the eye, they're already a little bit spread out. And then when they hit the lens of the eye, they will bend back and converge. But because they've been spread out a bit, it sort of changes where they hit, and it focuses them there. So see here, they're coming in straight, and they focus too early. Here, they're coming in a little bit stretched out, diverged, and then this bends them back in, but it gets them in the right focal point here for the eye. And so that's how glasses correct your vision. They are diverging lenses that help open up the light rays a little bit to compensate for the fact that they're too close together up here. It's very simple. And of course, different eyes of different shapes require different prescriptions of lenses, different sizes and different curvatures to get the right kind of bending. So that's a good example of where we find diverging lenses. We find them used often for corrective lenses for nearsightedness. All right, so there we go. That's images in curved lenses all wrapped up.